Hi everyone, I hope you're okay and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the second question from the May-June of 2024 Physical Sciences Paper 2 examination. We are doing question 2 and please do note that guys, the other questions are already uploaded and each and every one of those questions have their own video. I strongly believe that guys, knowing how to tackle exam questions will give you an edge whenever you write your final exam. So please guys, do share the video to your peers so that they may have the same edge as you. And please do help us grow the channel by just subscribing. Nah? Okay, we are answering an organic chemistry question. Nah? In this type of question guys, before we even answer the questions that they're asking us, nah, we need to focus on each of the following elements that are given. Nah? We are given letters that represent organic compounds from letter A to letter H. Okay, if ever guys you are given an IUPAC name, your duty is to draw your structural formula, and if ever you are given a structural formula, your duty is to write down the IUPAC name of your compound. And if ever guys you are given a condensed structure, firstly you need to draw your structural formula, and secondly write down the IUPAC name of that particular compound. Now, okay, compound A, we are given a butane 2-ol. Butane 2-ol is just an alcohol. How do I know that this is an alcohol? Because the suffix says ol. Are you together? That means at carbon number 2, I do have my functional group that represent alcohols. Now, okay, so the prefix says butane. That simply means that the longest chain has 4 carbons. So I have 1, 2, 3, and 4. And then at carbon number 2, I have my OH ion that represent alcohols. Then all I have to do is to just write down them hydrogens. This is an alcohol. The homologous series is just an alcohol. Yes, it is an alcohol, but it is a certain type of an alcohol. Now, it's a secondary alcohol. Why is it secondary? Because this carbon that has a functional group is bonded to 2 adjacent carbons. So that's why this thing is called a secondary alcohol. Okay, let's go to compound P. Compound P, we are given a hydrocarbon over here, and it's in condensed structure. So the first thing that we need to do is to draw the structural formula. We have CH3, we have C, and then CH3 there, as well as another CH3, and then we have 2 CH2s because of that thing over there, and then at the end we have just the CH3. All we need to do is to just write down the hydrogens. Write down the hydrogens. And then next, the next thing we need to do is to write down is to write down the IUPAC name. Now, we need to start numbering from the terminal carbon which is closer to the side chain. So this will be carbon number 1, 2, 3, 4, and 5. Are you together? So I know that at carbon number 2, I have my alkyl groups. So I'll simply say this is 2.2 dimethyl. The parent chain is 5 carbons, so the prefix will be pent, and then the suffix will be ane. Okay, and then now let's go to compound C. Compound C, we are given 3-ethyl pent 1-ine. This suffix over here tells us that we are dealing with a hydrocarbon, and the type of hydrocarbon we are dealing with is an alkyne. Okay, and the parent chain has 5 carbons since its prefix is pent. So I'll have a structure like this. Let me use a different color. 1, 2, 3, 4, and 5. And then at carbon number 1, I have my functional group for alkynes. That's a triple bond over there. Né? And then at carbon number 3, I have an ethyl like this. So all I have to do all I have to do is to just write down the hydrogens I have over there. Hydrogen, 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 another one, like that. Né? So this is our, excuse me, this is our structural formula for 3-ethyl pentoene, and this type of an organic compound is called an alkyne. Okay, and then now let's go to compound D. Compound D, we have an aldehyde over there. Né? Let's simply draw this structure. We have CH3, we have CH2, another CH2, and another one, and then we have C with an H and an O there. So that's how, guys, you're supposed to draw your structural formula for your aldehyde. Our aldehyde has how many carbons? 1, 2, 3, 4, 5. It should be pentane. It should be pentanal, ne? Yeah, just pentanal. The suffix has to be al, since you're dealing with aldehydes. Are you together? The homologous series rather for compound D is aldehyde. Okay, and then now let's go to compound E. Compound E, we are given an alkene. Why? Because I have a double bond there between adjacent carbons. So this over here will be my parent chain. Are you together? And obviously, guys, I do have side chains over there. And whenever I start numbering my carbons, I need to start numbering from the terminal, which is closer to my functional group. Are you together? So this will be carbon number 1, carbon 2, 3, 4, 5, and 6. Like that, né? Okay, and then the IUPAC name for this thing, I first need to mention the side chain or the substituent. There's the side chain over there at carbon number 3. I'll simply say I'll have 3-ethyl, and then the parent chain has 6 carbons, so the prefix will be hex. And then since the double bond is between carbon number 3 and 4, I'll always choose the smallest number between the two. That's 3-ethyl hex 3 in. Are you together? And this type of a compound is called an alkene. It's an unsaturated hydrocarbon. Okay, and then compound F, we have butane 1-ol. Butane 1-ol is an alcohol, and the type of an alcohol this is a primary alcohol. Why? Because the functional group for alcohols is at the terminal carbon, or rather the carbon which is bonded to the functional group is only bonded to one carbon. Yeah? Okay, butane simply means that there are 4 carbons on our parent chain, and then at carbon number 1 I do have my OH, and then I have my hydrogens like this. Okay, we can see that both compound A and F, both compounds A and F, both of them are alcohols with straight chains, and on those straight chains they have 4 carbons. The only difference is the position of our hydroxide ion. So basically compound A and F are just positional isomers. Okay, now let's go to compound G. Compound G is a haloalkane, because I can see the halogens over there. So this is a haloalkane, and whenever, guys, I start numbering, I must start numbering from the terminal carbon that is closer to the alkane or closer to the side chain. Are you together? Sometimes it can be both, from the carbon which is closer to both the side chain and the halogen. Okay, so this is my parent chain number 1. The parent chain should contain halogens, and secondly, it must have the most number of carbons. So that will be carbon number 1, carbon 2, 3, 4, 5, and 6. Okay, I do have substituents over here. Firstly, I have my halogens over there, And then secondly, I have my side chains over there. Né? And I need to mention these substituents in an alphabetical order. So chloro comes before meth for methyl. So I'll first mention the halogens. Né? So I'll simply say at carbon number 2, let me remove this. At carbon number 2 and carbon number 5, I have my chloro. I'll simply use di because I have 2 of the chlorines over there. So it's 2.5 dichloro, then hyphen, then I'll say 2.4 dimethyl. The parent chain has 6 carbons, so this will be hexane. That's 2.5 dichloro, 2.4 dimethyl hexane. This guys is our haloalkane. Yeah? Okay, and then over here, guys, we do have an aldehyde. How do I know that this is an aldehyde? Because I have a formyl group at the terminal carbon. I have a formyl group at the terminal carbon. Yeah? So these over here represent my parent chain. So the IUPAC name of this compound is basically 2.2 dimethyl prop. It's just propanol. Propanol. The suffix has to be al since I'm dealing with aldehyde. Compound H, guys, is a chain isomer of compound D. Both of these two compounds, firstly, they belong to the same homologous series. That means they have the same functional group, right? Secondly, they have the same molecular formula. The number of carbons and hydrogens are the same at compound D and compound F, and so does the number of oxygens. They have the same molecular formula. They belong to the same homologous series. The only difference is their chain length. Are you together? So compound D and H are just chain isomers. Now let's answer the questions, guys. Okay, they want us to define the term hydrocarbon. A hydrocarbon, guys, is just an organic compound that only consists of hydrogen and carbon atoms. Okay, and then now they want us to write down the letters for 2 compounds that are unsaturated hydrocarbons. The unsaturated hydrocarbons we have are only alkenes and alkynes. So compound C is an alkyne, compound E is an alkene. So C and E are the correct answers. Okay, 2 compounds that are chain isomers. Chain isomers are compound D and H. Both of them are aldehydes. They belong in the same homologous series, and that means they have the same functional group. Secondly, they have the same molecular formula. The number of carbons is equal to the number of carbons, hydrogen, and oxygen is equal for compound D and compound H. So they have the same molecular formula. The only difference is in their structure. Are you together? This compound is branched, whereas compound D is a straight chain organic compound. So compound D and H are just chain isomers. D and H are chain isomers. And then they want us to write the letter that represents a secondary alcohol. I said a secondary alcohol is compound A because the carbon which is bonded to the functional group is also bonded to 2 adjacent carbons. That's why compound A is a secondary alcohol. Okay, now they want us to write down the structural formula of the isomer of compound D. Functional isomer. Functional isomers of aldehyde, guys, they are always ketones, né? So we just need to write down the structural formula of a ketone that has 5 carbons. 5 carbons on the parent chain, né? The structure will just look like this: 1, 2, 3, 4. And then you can choose where you want to put your double bond O, or rather your carbonyl atom. Either at carbon number 2 or carbon number 3 is definitely up to you. Né? So these over here will represent the structural formula of our functional isomer. We either have a butane, or rather pentane 2-one or pentane 3-one. You can remove this and put it here together, and then you'll have pentane 3-one. But I chose to draw a structural formula for pentane 2-one. Okay, write down the general formula of the homologous series to which compound B belongs. Compound B is an alkane because we have single bonds between adjacent carbons. So it's just the hydrocarbon that has single bonds between adjacent carbons. Né? So the general formula for alkanes is just CnH2n plus 2. Then the structural formula for compound C. Compound C is 3-ethyl pentane. We've already drawn it there, né? So, but it's fine. We can redraw it. It's 3-ethyl pent 1-ine. So the parent chain has 5 carbons. That's the first thing I need to notice. And then first carbon, I do have my functional group, which is a triple bond. And then carbon number 3, I have my ethyl over there, like this. And then I have my other hydrogens over there. So this structure will represent 3-ethyl pent 1-ine. Okay, they want us to write down the IUPAC name of compound E. Where is compound E? Oh, compound E, we've already dealt with that. We said it's 3-ethyl hex 3-ene. That's 3-ethyl hex 3-ene. And then for compound G, we said it's 2.5 dichloro and 2.4 dimethylhexane. That's 2.5 dichloro and then 2.4 dimethylhexane. Please note that, guys, between my numbers and letters, I always have a hyphen. Okay, the IUPAC name for compound H, we already said it will be 2.2 dimethyl propanol. That's 2.2 dimethyl propanol. Okay, now they want us to use compound. We're told that compound B rather undergoes complete combustion. Use molecular formula to calculate the balance use molecular formula to write down the balance equation for this reaction. The molecular formula for compound B, I have how many carbons over there? It's an alkane that has 7 carbons. 1, 2, 3, 4, 5, 6, 7. Yes, it's 7 carbons. If I have 7 carbons, it simply means I will have 16 hydrogens. So I must write down complete combustion of that molecular formula. It has 7 carbons and 16 hydrogens. For complete combustion, guys, you will always react an alkane with oxygen, and your products will forever be water and carbon dioxide. Always the time, By just writing this thing, guys, you already have 2 marks. Then the other mark will be from balancing the equation. I have 7 carbons over there, but I only have 1 there, so I must just write a 7 there. I have 16 hydrogens, but I only have 2 over there. That means I must write an 8 over there. And then now let's calculate the number of oxygens. Whatever number of oxygens I have over here, if I have 200 oxygens, the coefficient over there should be half of 200. If I have 50 over here, the coefficient over there should always be half of 50. Okay, let's just do that. Okay, the number of oxygens, I have 8 plus 7 times 2, that's 14. 8 plus 14, that's basically 22 oxygens. So in total, on the right hand side, I have 22 oxygens, that means the coefficient over here should be half of 22. That's 11. So this is the complete balance equation for my combustion. That's how, guys, we're supposed to tackle that question over there. So please do stay tuned and wait for more videos. Thank you.